All right, we have learnt about APs, the arithmetic progressions, where we're adding or subtracting on from the previous term to get the next term. And then we learnt about GPs, which is when we're multiplying by something as we go along with the terms. Now we're just going to do some general problem solving involving both of those two types. So it says that we will sometimes need to solve using simultaneous equations to eliminate A for an AP. Subtract equations. To eliminate A for a GP, we're going to have to divide the equations. Okay, let's have a look. Example number 1. Find X if 6X and 54 ... is an AP. Now we know to find the difference in an arithmetic progression, you would subtract the second term minus the first term. So that would be, I can't write with that pencil, that would be X minus 6. But that would also be equal to the 54 minus the X. So equals 54 minus X. Both of those things work out the difference. So if I make them equal to each other, I can solve that for X, right? So let's move the negative X, move it across to this side, would become 2X. And while we're at it, the minus 6, move it to that side, would become 60. If we divide by 2, we get X is equal to 30. Okay? That's it. I have found X. That's all I had to do. Question 2 looks really similar. It is the same numbers, 6X and 54, but now we want it to be a GP, a geometric progression. Okay, so small difference. Which means if I want to find the ratio, the R, you would divide X divided by 6 would give you the ratio. But the ratio would also be equal to the 54 divided by the X. Do you see what I'm doing?
Yes.
Yes, it makes sense? And I want to solve that for X now. So we're going to cross multiply. X times X is X squared. And 54 times 6.
300.
Good. Okay, that's X squared. So if I want X, I have to square root. Good, I'm very glad that you remembered the plus or minus. Because it could be a negative 18. If you started here and you went 6 times negative 18, I don't know what that is, but you... Lachlan, you're the multiplying person, aren't you?
What did you say?
6 times negative 18.
Negative 108. Yeah.
Oh, you got in too quick. Anyway. And then if you times that by negative 18 again, it will come back to a positive... that's not the right number. It's not 18. X is the number, not the ratio, sorry. The ratio would be, the 18 would be negative 3. So I worked out the X, not the R. The X is negative 18. If R was negative 3, go 6 times negative 3 gives negative 18. And then to times by negative 3 again, you come back to a positive 54. So it works for a positive number or a negative number in that middle position, is what I'm trying to say in a weird way. Sorry, I messed that up a little bit. Okay with that? All right, question 3. The 8th term of an arithmetic sequence is 29 and the 22nd term is 71. Okay, these kind of questions I like to start listing off the information that I'm being given. So over on the side, the 8th term, which means T of 8, is equal to 29. And the 22nd term, so T22, is going to be equal to 71. So there is 2 equations that I'm going to make from that I'm going to have to solve simultaneously. Now they are both arithmetic progressions. What is the formula for an arithmetic progression? T of n, I'm hearing rumblings of it, equals A plus n minus 1 bracket d. These formulas are all on your formula sheet, okay? So don't stress about them. Let's start with the T of 8. T of 8 is equal to 29, so I'm going to put the 29 there. I don't know the A. I do know the N. What's N?
7, 8.
It's 8, but when I subtract the 1, I know what you're doing, Ben. You get the 7 times D. And there is one equation. I'm not going to call that equation 1, though. What I'm going to do is I'm going to get the A by itself first. So A equals 29 minus 7D, and I'm going to call that equation 1. Now let's look at the second bit of information that we were given, which was that term 22 is equal to 71. So we're using the same formula, but now the term is 71 equals A, I don't know, N, this time is 22, but subtract 1 will be 21D. Okay? And again, I could rearrange that to get the A by itself, which would be 71 take away 21D, equation number 2. So I have two equations that both have A and D in them, so I'm going to solve them simultaneously to find out what they are. Okay, so I'm going to go back over here on the other side. So I'm going to sub equation 1 into equation 2. That will be 29 minus 7D is equal to 71 minus 21D. Okay, because they were both equal to A, it just means that that part is going to be equal to that part. Or you're just replacing that into that, the height of that equation there. I'm going to circle that. I'm taking this and I'm putting it into there where the A is. Okay, now I want to solve that for D. So I'd like my D positive. So that minus 21, let's move it over to the other side. It'll be minus 7 plus 21, which makes a positive 14D. And the 29 that is here, subtract it to that side. So 71 take away 29 is 42. Okay, I know I'm doing two steps there at once. Is everyone following along okay? Good. All right. Then divide the 14. D is equal to 3. Okay, that's not enough. I still need A. You can choose where you substitute it back into, equation 1 or equation 2. Doesn't matter. Equation 1, excellent. Okay, so that would be A equals 29 minus 7 times 3, which equals, anyone got it? 8. Perfect. So the question said to find the first term and the common difference. A is the first term and D is the common difference. We're done. Next page. Question 4. The third term of a geometric sequence, okay, so we're changed to a geometric sequence now, is 45. So I'm still going to write down here, term 3 is equal to 45, but I'm going to be using a different formula for a GP. The 8th term, so T8, is equal to 10935. Find the first term and common ratio, because it's a ratio for a GP. Okay? So the formula, does anyone know that one? For the term of a geometric. Yes, I'm sure you all said it perfectly. T of n equals A r to the n minus 1. For the first one that I've been given, my term is 45. A, I don't know. R, I don't know. N is 3, but let's subtract the 1 off, so that'll be a power of 2. Now, for when you're doing a geometric series, like we probably could have done an elimination. We could have tried to do that with the other one there. But when you're multiplying, these ones definitely have to be done by substitution, okay? So you want to get that A by itself. R is a bit tricky to get by itself because it's going to have the power on it. But the A is 45 over R squared. And that's going to be my first equation. Okay, then the other one, using the same formula, this time my term is 10,935. A, don't know. R, don't know. but my n is 8, subtract the 1 will be a power of 7. Again, get the a by itself. A equals 10935 over r to the power of 7. Okay, that's equation 2. Okay, so let's fill it in over here. We are now going to substitute equation 1 into equation 2. So I'll use my red pen to show you how that works. The 45 over r squared is going to replace the a in that second equation. So that will be 45 over r squared equals 10935 over r to the power of 7. Okay, so we can do some switching positions here. I want to get the r's together on one side and I want to get the numbers on the other side. So if I multiply this r to the power of 7 over to this side, I'll be able to divide it with the r squared that's there. So let's do that. I'm going to bring the r to the 7 to the top and there'll be an r squared on the bottom. But the 45 that is here, I'm going to divide it under that one. So it's going to be 1095, that number, whatever that is, 10,935 over 45. Okay, you could just do your cross multiplying and then go from there, but this is probably a shorter way to rearrange that, as long as that makes sense to you. Did it make sense what I did? Okay, so the r to the power of 7 divided by r squared, you subtract those powers and that will become r to the power of 5. And divide those numbers, I think you should get 243. Did anyone check that for me?
Yeah.
Great. Okay, so r to the power of 5, if I want r by itself, it means I need to do a fifth root. Hopefully you can find that on your calculator. A fifth root of, fifth root of 243 is 3. I have found r. I still need the first term. So let's go back into the first one. So a will be equal to 45 over 3 squared, which is 45 over 9, which of course, yes, is 5. Okay, so I found my first term of my common ratio. These are kind of fun. They take a little bit of working out sometimes, but yeah, they often come out nicely. Don't always expect perfect answers though. One more. Question 5. For a GP with a equals 5 and r equals 2, find the first term that is greater than, is that a million? Yes, all right. So we want our term, T of n, to be greater than 1 million. Our term formula, which it's a GP, so it's the one that we've just been doing, is the AR to the n minus 1. We do know a few things. We were told that A is equal to 5 and we're told that R is equal to 2. So if I sub these into that expression, that's my term, right? So it's going to be 2 times R, which is, sorry, wrong way around. 5 is the A. 5 is A times 2 is R to the power of n minus 1. That's the general form of my term. That has to be greater than 1 million. Now I have to solve that to find n. Do not times the 5 and the 2 together. I have to divide the 5 across to that side. So that will be 2 to the power of n minus 1 is greater than, and 200,000 is what that equals. Okay, so you could try and get 200,000 with a base of 2, but that's not going to come out very nicely. So instead we're going to do a sliding base. We're going to keep the n minus 1 here on the left, slide the base 2 across, so log base 2 of 200,000. And, sorry? Sliding base. Oh, yeah, I will do a change of base to type it in the calculator. But before I do that, I'm just going to move the 1 across as well. So log base 2 of 200,000, and it's going to be a plus 1 on the end. So to type that into your calculator, because we can't do a log base 2, you can type in either of your log buttons, so maybe the ln of 200,000 over ln of 2, and then you plus 1 over on the side. I got, and hopefully you will get, 8. Do I get to plus the 1? 18.6? Yes? So if we know that the position has to be greater, that's why we have that sign in there, n has to be greater than 18.6, the first term will be when n equals 19.
Like Miss, I split it into 2 to the power of n times 2 to the power of negative 1 and divide that across.
That'll work. Yeah, absolutely. No worries. Just doing more index laws. Okay, so that's what we were after. Find the first... Oh, no, wait. No, we're not. I haven't finished. That's the position. The question says to find what the first term is. Better make sure we read that. It's always good to go back and read the question to make sure you finished it.
So do we need to 19?
Yeah. So, guys, nearly done, but not yet. If the question says find n for the term that first exceeds 100,000, I just need to find the n. But if it says to find the actual term, I need to find out the term in the series. So we have to put that 19 back into our formula. T of 19 is equal to, it was 5 times 2 to the power of n minus 1, but subtracting 1 will be 18 in there. I don't know what that is.
131072.
131072. Oh, cool. All right, now we're done.